So this question here, we're looking at purifying some copper using the process of electrolysis. And we have got our impure copper here at the anode, and we've got a strip of pure copper at the cathode, and it's sat inside a solution electrolyte of copper sulfate. So what we need to do is three things to do. We need to talk about the sizes of the anode and cathode. We need to talk about a solid that appears underneath the anode, and we need to talk about the colour of the copper sulfate. So let's deal with these as we go through this. To help with this, I've put these equations on. So this is the impure copper anode. So here we start off with copper. The copper atoms become copper ions, which are Cu2+, and to do that they release electrons. Because that is the loss of electrons, this process is oxidation. And what this means is, as this happens, this electrode here is actually going to start to become smaller as the copper forms copper ions. Now those copper ions are going to go into the solution. So here we have our copper ions in solution. Once those copper ions in solution, they're going to migrate and travel, be attracted to the cathode, and at the cathode they are going to gain electrons, as this equation shows, and form copper metal. So what we'll actually see happening here is new copper metal forming on the surface of the electrode. So this electrode here is actually going to start to get larger as those copper ions become copper atoms. So that's the first bit about the sizes. Okay, so this one here, the anode will become smaller as the copper ions are released into solution, and here this will become bigger as the copper ions form copper metal, and you must be including these equations in your answer. Okay, next one, the solid underneath. So here we will get a pile of impurities forming. So as the copper atoms become copper ions, the impurities come out of the metal as well and sink to the bottom, and we get a pile of these underneath the anode. Okay, so that helps with this part of the question. And then the colour, well, every time we get a copper ion forming, the copper ion comes across here and turns into copper atoms. But this means that the concentration of copper in the solution here remains constant. So all we need to do here is to explain that the concentration of copper 2+ ions remains constant, and you can explain that using those equations to help you. And that means that the blue colour will remain the same intensity of blue. It won't become darker, it won't fade as this reaction starts to proceed.